Now we're looking at how we can actually run a t-test, where, like I said, we're sticking with that GDP data, and it's going to be our friend for a while because it's good to have something consistent here. But we want to test the significance of the correlation coefficient, where in these cases, we're either testing if there's correlation or if there is not, so we don't really have a claim in the way that we used to. We're looking at that value rho, we're see does it do it, does it not do it. And to do this, yeah, there's a bit of a process we can follow that's very similar to before, where we have to be careful with the degrees of freedom here. In this case, we have that the degrees of freedom follow the pattern n-2. I think it's a representation of the fact that we have two data sets here, but in this case with alpha equals 0.5 and df equals 8, if we want to get the critical values, in this case that'd be a pretty simple inverse t computation. Area here is going to be 0.975, or whatever it would be if you have a more advanced calculator. Df is 8. And we get the upper critical value here is about 2.306. And I don't know why it does, but the book here just completely refuses to acknowledge the p-value versions of these tests for this section. So we're not going to see too many of them, but when we do see them, they have to use critical values. It's frustrating, but this is what we get for our critical value. From there, if we want to actually run our test, we need things like a t-value and all those other pieces. We have our special test here, which I mentioned in the last video, the Linreg t-test, where we're running list 1, list 2, and remember, we're looking for the two-tailed variant, rho is non-zero, where we're not going to store the regression equation just yet. That's something we'll see in later sections, but we calculate that, and among other things, we get our desired t-score, along with a p-value, where again, even though the book doesn't talk about these things in terms of p-values, we can see that that's actually a very small p-value. In particular, that's a p-value that's much smaller than alpha, or if you prefer, as the book does, that t-score will be well inside of our rejection region on the top end. That is, 5 is bigger than 2.3. So, as a result here, we would reject the null hypothesis, which is to say there's enough evidence to conclude there is a significant linear correlation between GDP and CO2 emissions. And that's kind of a nice thing about these kinds of tests in particular, though, is that because we don't have claims, there isn't that subtlety about how we want to state our conclusion. Either we have evidence to conclude strong, significant correlation, or we don't. There isn't that gray area, as there were with the other cases.